Hello everyone, welcome to this video all about geometric operations, which is a type of measurement and data question. This video is going to focus all on the topic of height. Height refers to the measurement of an object. It's usually measured from the lowermost point to the highest point. Height questions will involve knowledge of properties of geometrical shapes, which means we should have a basic knowledge of 2D and 3D objects to answer these questions. Usually they are fairly straightforward and easy to interpret. Complex questions may utilize harder 3D objects and require you to determine height and calculate area or volume. Okay, so height really is just one more dimension or measurement of a specific kind of shape. We see height in even 2D shapes as well as 3D shapes. For example, when we calculate things like the area of a triangle, it's always calculated from the height, and it doesn't really have a length or width since triangles are more to do with bases and heights. So in reality, it's just another name for one of the dimensions that compose a certain shape. With 3D shapes, however, height is a bit more easy to understand because, well, we've got the extra third dimension, so we can see how tall something is, and that's generally going to be our height. Now, we can see that because at the end of the day, height is just a dimension. We can see how it's going to relate to a lot of the times things like area, maybe perimeter, or even volume when we're talking about 3D shapes. So that means we need to have a good knowledge of how to figure out those kinds of things. Now, generally for those things, as long as we understand the formulas for those questions, they are typically straightforward to answer. So let's go through the more basic shapes. We understand that for rectangles or squares, we can figure out the area. That is quite the terrible rectangle. Let's draw it again. Since we've got two sides that are equal, the area is just going to be length times by your width. Now, because height is just one of the dimensions, sometimes I'll give you one of these as the height, and that might be the case. If we've got things like the triangle, as we talked about, this is definitely where they do have a specific side for the height, and that's always going to be the, what do you call it? How tall the triangle is rather than the length of the size of the triangle. So for the area for the triangle, it's always going to be half times base times height, no matter what the triangle is shaped like. We've also got things like, for the 2D shapes, that's kind of it, but we've got 3D objects where the height becomes quite important because for finding out 3D objects, if we figure out the area of the base shape, then multiply it by the height, then we get the volume of a prism. And that's going to be particularly important if we ever have more complicated base shapes. For example, something like this, and it says figure out the volume of this prism, and you go, oh my gosh, how do we figure that out? But they give you the area of the base shape, then you know, or even if it's such a complex shape as this one, all you need to do is multiply the area by the height to get the volume. So we can see that by utilizing more basic knowledge, we can figure out the volumes or areas of more complex shapes like this. And that would always be one of the key things to keep at the back of your mind. Even if you come across a very difficult shape, see how you can break it down into more easier, manageable chunks and see how you go from there. So let's see if we can try that out by tackling this example question. Here, this question says, Eastwood Council has decided to construct the new parking space near the shopping district. The area of the parking lot must be 43.55 centimeters squared at least, but the shape of area would be a trapezium due to another ongoing construction in the next street. We're told the bases of the trapezium are 5.6 and 7.8 centimeters respectively. What would be the height of the trapezium? Okay, so here it looks like they're building a parking space for ants because the units are in centimeters squared for some reason. But aside from that little funny thing I wanted to mention, this question wants us to figure out the area of a trapezium. Now, trapeziums are definitely one of the more harder 3D objects. We usually deal with things like rectangles, circles, and triangles, so a trapezium may be a bit of a surprise. And trapeziums do have their own formula that you can use to very, very quickly figure out the height. So let's see what we can do, say, for example, in the scenario where we have actually memorized the formula for the area of a trapezium. Now, it's not too difficult. We know that trapeziums are shapes that looks like this. So the question tells us that the bases of the trapezium are 5.6 centimeters and 7.8 centimeters respectively. So trapeziums have a longer side and a shorter side, so that's what they're talking about. And the question wants us to figure out the height of the trapezium. Now, one last piece of information that they've told us is the area of the parking space. So whenever you have questions like these, the first thing I would always do is draw a diagram of the important information, and that just allows you to quickly see all the important information without having to go through the question and reread the details. This is just a much faster way of jotting down all the things we need for the question. So once we have done that, we can now see what we can do with the information we jotted down. So we talked about how there is actually a formula for the area of a trapezium. So if we have the area of trapezium, it's found with the formula where we actually add a plus b divided by 2 times by the height. And if you're wondering what a and b are in this scenario, for a trapezium, we talked about how there's a short side and a long side, and we're also given the height. So these two lines are basically what we use to figure out the area of a trapezium. So the question has thankfully provided us that information. So all we need to do is substitute the information into this question, this formula. A is 5.6 and B is 7.8. We know the height. We're looking for the height, and we're dividing that by 2 to get the answer of 43.55. So we can see that by rearranging this equation, we can then figure out the height. So we want the height to become the subject of this sentence. Now there's a few things going on here, so let's simplify this equation a little bit. So let's see if we can get rid of the brackets first, always adhering to the laws of BODMAS. If we simplify this part of the sentence, it becomes 13.4 when you add 5.6 and 7.8 together. So we've got an equation that looks like this at the moment. So let's see if we can rearrange everything to get h to be the subject of the sentence. If we multiply both sides of the equation by 2, we get rid of that. Then if we divide everything by 13.4, these cancel out, and we're left with h is equal to 43.55 times by 2 divided by 13.4. Now that's a bit of a difficult calculation to do by hand, but if you do the maths correctly, we get the answer of 6.5 centimeters. So the correct answer is then going to be option D. So that's all fine and dandy, but what if we don't actually know this formula? Because trapeziums aren't that common when we see them in maths questions. So what if we never memorize this formula? Well, that would be where we don't try not to panic and see that even if we're dealing with such a difficult shape, let me just draw that properly. Even if we're dealing with a more difficult shape like a trapezium, at the end of the day, we can see that we can break it down into the more simple types of pictures or shapes. If we split the trapezium down like this, we're left with what's essentially a rectangle and a right-angled triangle. Now, the information we have still applies. We have 5.6 centimeters here, and we have 7.8 centimeters for this entire length. Now, the question is, we want to figure out the height of the trapezium, and we're trying not to use this formula because we remember, in this scenario, we don't know that formula. So what do we do? Well, let's see if we can tackle this using the two composite shapes. For the rectangle, if you only wanted to figure out the area of the rectangle, then that would be by doing your length multiplied by your width, 5.6 times by h. Now, if you then only wanted to figure out the area of this triangle, then we would use the fact that this entire length is 7.8 centimeters and this length is 5.6 centimeters to figure out what this length is. And that's just the difference between those two numbers. So if we do that, that should give us 2.2 centimeters. Now we know what's essentially the base, and we also have a value for the height of the triangle, which is just going to be our h. So if we find the area of that, that's going to be 2 times 2 times half times h, which we can simplify to 2 going into 2.2 1.1 times, giving us 1.1 h. Now remember, if we add these two values together, then we're meant to get the area of the trapezium that they gave us in the question. So let's do just that. 5.6h plus 1.1h, which is these two areas respectively, give us the entire area of the trapezium. And we can see we can simplify this part of the question further. 5.6h plus 1.1h both have the same pronumeral, so we can collect like terms to get 6.7h is equal to, 43.55, and we can then rearrange to make h the subject of the sentence, giving us 43.55 divided by 6.7, giving us the exact same number of 6.5 centimeters. So we can see that even if we didn't actually know the formula for more complicated shapes, if we just break it down into ones that we are more familiar with, it's entirely possible to also get the answer in roughly the same number of steps as we did it with the formula. Hopefully this video was of some help to you guys. Thanks everyone so much for listening.